Today we're going to take a little review of the metric system, and we're going to look at significant figures. These are some of the most common prefixes that we'll see in chemistry, especially kilo, deci, centi, and milli. And then nano will come into play later on when we're talking about the size of atoms. So I just want to take a second and review them, or for you to be familiar with them. I know this is something that you've already previously learned. Significant figures is what we're really going to talk about today. Significant figures are the reliable digits in a measurement based on the measuring instrument. And so what that is telling us is how well we can measure something. How precisely does that tool measure something? And we'll do a demonstration in class that will help illustrate that. But just to teach you the idea of how to actually find significant figures, we're going to learn the Atlantic and Pacific method. And that means we need to know which ocean is the Atlantic and which ocean is the Pacific. Atlantic, A, is going to stand for decimal is absent, and to begin counting your number from the right. P means the decimal is present, and you begin counting from the left, or the Pacific side. So absent from the Atlantic side, P present from the Pacific side. And this is best illustrated through examples. So if we have a number like 1,000, so first of all, let's, I'm going to get some of my artwork here. I'll draw a map of the United States. So we should all know that Jersey Shore is the Atlantic, California is the Pacific. In this case, the decimal is absent, so I'm going to start counting my significant figures from this side of the number. However, I can only start counting numbers once I hit a number that's not 0. So 0, 0, 0, I don't count. This is my first number, and anything to this direction would be considered significant. In this case, this number has one significant figure. If I look at this number, a decimal is present because I have a decimal right here. So I'm going to begin counting from this side of the number. I don't count until I hit a number that's non-zero. So I have a 0, I have a 0, I have a 0, and there I have 1. And anything past that 1 would also be significant, but there's only a 1. And so in this case, we have 1 sig fig. In this one, again, my decimal is present, so I'm going to start from this side. I'm not going to count this, I'm not going to count this, I'm not going to count this. I start here, and everything after this 1 is considered significant. In this case, I've underlined 2 numbers. And so I have 2 sig figs. And in this one, again, this decimal is present, and so I'm going to start on this side again, but I'm starting right off the bat with a number. And so everything past this 1 is significant. So it's 1, 2, 3, 4, 5 significant figures. Notice that this number and this number are the same number, but they have a different number of significant figures. This one is measured much more precisely. This number and this number are the same number, however, this one here is measured much more precisely. Here's a few more to try. The decimal again, so I can draw my little bad map again. Oh, it got worse this time. Decimal is present. I'm going to start here. This is a number, so everything after that number is significant. So I have 4 sig figs. In this case, again, my decimal is also present, so I'm going to start here. I have a lot of examples with present. So this number is significant, and everything after it is also significant. Oh, my 2 didn't get underlined there. So again, I have 4 sig figs. My decimal is present in this case. I'm going to start here, but I don't start counting until I hit a number, which in this case is 3. So significant figures in this case is 2. And this one we have no decimal, so I'm going to start here. I don't start with this 0, I don't start with this 0. I start with this 1, and even though this number, even though these are zeros, this 1 starts it, and everything to that side is significant. So I have 4 sig figs in that case. Rules for using significant figures in multiplication and division. The number of significant figures in the result is the same as that in the measurement with the smallest number of significant figures. So, in this case, I'm multiplying a number. This has 3 sig figs. This has 2 sig figs. 3, 2. This is what I get when I put it into my calculator. However, I need to round this number to my smallest number of sig figs, and in this case it's 2. So my final answer has 2. The same would be true for division. So if I have, erase that because that's on top of that. I have a number here with 4 sig figs. I have a number here with 3 sig figs. I divide it. This is what my calculator gives me, but I know 3 is the smaller one, and so now I have to round it so that there's 3 sig figs. In addition and subtraction, the rules are a little bit different. The limiting term is the one with the smallest number of decimal places, which is different. So if I look here, I have 2 numbers after the decimal, I have 1 number after the decimal, I have 3 numbers after the decimal. I add them together, that's what my calculator tells me, but since this number here has 1 number after the decimal, this answer can only have 1 number after the decimal. And so I rounded. 31.123 rounds to 31.1. Scientific notation, this should be review as well. It's something times 10 to an integer, where m is something that's between 1 and less than 10, and n is the integer. And I think we're pretty familiar with this. We know that if the number is big, that this the exponent is going to be positive. So my imaginary decimal is here, and so I move it 1, 2, 3, 4 places, and so then I end up with 2.5 times 10 to the 4th. In this case, the decimal is already here. I'm going to move it so that it's 1 place past the 4. So I'm going to have 4.68, and because this number is less than 1, I have 4.68 times 10 to the negative 3. Again, this number is a small number. I'm moving my decimal to the right. When I move my decimal to the right, and I have to be careful to write 1.00. I'm going to copy this exactly. I'm not just going to write 1 times 10 to the negative 2, because this is 3 significant figures, and so this number has to be 3 significant figures. This is 2 significant figures. This is 2. This is 3, and so this is 3. And that will be the rest of our lesson for today. Accuracy and precision will start our next lesson.